So let's say you have a bank account, and in that bank account you have some money. For example, you have 100 rupees in your bank account, and there are two users, user one and user two. Both users are trying to deposit some money to your bank account. Let's say user two is trying to deposit 50 rupees, and user one is trying to deposit the 100 rupees to your bank account. So what's happening here is, at the same time, user one is trying to deposit the money, and user two is also trying to deposit the money to your bank account. And um, since they are reading the bank balance at the same time, they both see that there's 100 rupees in your bank, and user one tries to add 100 rupees to your bank account, and then it deposits that amount to your bank account. So now the balance is 200. Since at the same time user two is also trying to add or deposit 50 rupees to your bank account, what would happen in this case is, the total is 150 rupees, and when user 2 would deposit that amount to your bank account, whatever was there previously, when I say previously, I'm talking about the user 1, will be overridden by user 2, because they both have read the same amount at the same time, and user 2 will override 200 rupees of balance with 150 rupees. So this is a lost update problem, and you see everywhere in your day-to-day life, wherever you see that multiple users are trying to access the same database or trying to access the same resource. For example, IRCTC, multiple users are trying to book the same seat in same train. This is one of the example, and there is one more example like Book My Show. Two users trying to book the same seat in same theater at the same time. If concurrency is not handled at the back end, you see this loss update problem everywhere. So the solution to this problem is, I'll discuss on two solution: pessimistic locking and optimistic locking. So I'll discuss first about the pessimistic locking. So in pessimistic locking, what happens is that user actually apply a write lock on the record, so that other users cannot update the same record, and corrupt the database. So what happens in optimistic locking is, so for example, user one is again trying to update the record. So before updating the record, it is acquiring the lock on that particular record, and then it's reading that record from the database. At the same time, user 2 is also reading the record from the database, and since it's a read lock, since it's a write lock, user 2 was able to read the same record because there is no read lock on that particular record. Now coming back to user 1, so user 1 now add some update on that particular record. For example, it's adding 100 to that initial value of x, which was 100, and now the updated value is 200, and then user 1 is saving that 200 to the database. So what happens next is, user 2 also try to update the same record in the database, and since there was a write lock applied on that particular record, user 2 was not able to update that particular record because the lock is applied there. Next, what happens is, user 1 released the write lock, and until the write lock was released, user 2 will wait, and once the write lock is released, the user 2 will again read the same value from the database, the updated one, and add 50 to it, update it accordingly, and then it saves that record back to the database. So now what happens here is, user 2 is not corrupting the database because there was a write lock applied by the user 1, and user 2 actually updating the correct record here. The major drawback of this pessimistic locking is that when there are n number of users, they all have to wait until the ongoing ongoing operation is completed. For example, we have 1,000 customers trying to access the same record, and until any ongoing operation is completed, nobody will be able to access the record, and it will be completed in a linear way. So if we have 1,000 customers trying to access the same database, and every user is taking 1 minute to update the record, the last customer will take 1,000 minutes to get its turn, and will be able to update the record after 1,000 minutes. So one more point I would like to highlight here is that, so user, when there's a write lock, user 2 won't even be able to modify the record. So it is, do not get confused from this modify x equals to x plus 50. Even user 2 will not be able to modify the record, let alone saving that modified value to the database. That's why this pessimistic blocking is time consuming in nature. So the simple solution to this problem is this optimistic locking, where we maintain a version, right? So for example, user one is trying to access some record, and record would have some kind of versioning to it. For example, version v1.0, and at the same time, user two is also reading the same record, and the record version is 1.1.0. So when user one tries to update that particular record, what happens at the backend is, let me open the blog I have written on this topic. So user one tries to update the record, and what happens at the backend is it actually matches the version it has with the version that particular record has in database. So when it actually read that particular record from the database, the version was 1.0. So as it has the version, it has the version 1.0, and it actually matches that particular version from the database version. So both versions are same, 1.0. It's a match, and there is no update to that particular record. When I'll explain about the user 2, you would understand about this versioning thing. So both of the version matches, and then user 1 actually updates that particular record to the database, as well as it updates or increment the version from 1.0 to 1.1. Now, what happens next is user 2 modify that particular record and tries to update that record to the database. Now, what's happening at the backend is when user 2 read that particular record, the initial version was 1.0. If you see here, this was 1.0 when user 2 read that particular record from the database. It modified it to something, maybe 1.2. And what happens here is it actually matches that 1.0 with the current version of the record, which is 1.1. So 1.0 is not matching with the 1.1 because there is an update on that particular record. So what happens next is user 2 would read the latest value of that particular record, and then it will get the latest version as 1.1, and then it will update the record, and then will save with the incrementation of that versioning, and will save it back to the database. So the benefit of this particular approach is that in the pessimistic locking, multiple users were not at all able to even update the record, let alone saving to the database. But in optimistic locking, users can independently update the record at the same time while others are also updating the record, and they are not stopped to update the record. What they are stopped for is that they cannot save that particular record to the database. So it is quite faster than pessimistic locking, and that's where we use the optimistic locking.